Welcome to the Stormsurf video surf forecast for the week starting Sunday, August 26th. Looking at significant wave heights for the South Pacific Ocean, we see actually a gale generating 35-foot seas over a small area. But the issue is these seas are actually falling southeast into the Ross Ice Shelf right here and not doing a whole lot. No swell is really expected to radiate north. Otherwise, you look around, you see, a couple of patches of 20-foot seas. That certainly would not survive the long journey radiating up towards California or Hawaii. And so no swell is expected from that. So in essence, we continue with basically a calm sea state in the South Pacific. Let's get into the details. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, and we don't really see one. Yeah, that's kind of a trough there. That is a push in the southern branch of the jet stream to the north. So yes, that would qualify as a trough, but there's not enough wind pushing north. You really want to see at least like 100-knot winds minimum pushing to the north to help support. That would support a clockwise flow aloft and in southern hemisphere. That's the sign of low pressure, and that also manifests it down at the surface. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, generate swell. Swell, when it hits your beach, creates surf. So yeah, there's kind of a trough here in the far southeast Pacific. There's also kind of a trough here, sort of southwest of New Zealand. But the problem is we have this ridge that is the exact opposite of trough. It's the jet falling south right here. And the ice line, if you happen to notice it on the previous chart, it was somewhere around 63 south, so right along in here. So yeah, there's a little tiny area here north of the ice line that has unblocked ocean water available to generate swell, and another little area right here. But all this pushing the jet to the south is just pushing the jet over Antarctica, doing nothing to promote storm formation. So, and it is the southern branch of the jet, this one right here, not this one here, that really helps generate or helps fuel storm development. So we'll roll this out. The model only goes a little way before it kind of crashed. NOAA's having some problems here, but as we get into Monday, you see a pure zonal jet stream flow running right around 60 south, and no troughs, and not even a whole lot of energy in it, not really doing anything to support gale development. And as we get into Tuesday and Wednesday, then we see a little bit of a trough trying to organize here over the central Pacific, and a ridge, it looks like, starting to build from the west. Roll this out a little bit more, and then you see this trough, but again, winds, yeah, one little pocket, barely to 100 knots, but that's not doing a whole lot, with a ridge in the far southeast Pacific, ridge in the West Pacific, just doing nothing to support gale development. And now the new ridge starts building. At any moment here, the jet, or there we go, the model will sort of freak out on us. But you can still get a sense of where. So notice, ridge here, little weak trough trying to build here in the southeast, ridge in the west. We go to the next frame. You can kind of follow the isobars and see what's going on. See the arrows, they're all going to the north. That's why. So the wind direction is really the issue here. But you can see the ridge, look for the ridge here, and then the trough in the west, and you can just sort of step through this and see big ridging pattern taking over by Saturday and into Sunday, and just offering, no help at all for the jet stream. All right, let's go take a look at surface level charts. And here we go, surface level pressure, surface level winds, and yes, there is some fetch right here, 35 knots above the ice line. What is that? And those winds, for the most part, are pushing pretty much southeast, maybe a little bit to the east, but mainly southeast, and that's where we saw those seas that were, 35 feet, and as you watch this, that all just disappears in the next 24 hours as we get into Monday, and then we're looking for some sort of a low. There's a little bit of a bend there with 35, almost 40-knot winds, but it's got to actually survive with some duration. Yeah, it's kind of doing that, giving you this sense. You really want to generate meaningful swell. You need at least 40-knot winds, if not 45-knot winds. When you're in this area, 6,000 plus nautical miles away from California and maybe 5,000 from Hawaii. So we're kind of looking, yes, okay, there's some pockets of 35-knot winds. There's a pocket of 35-knot winds pushing southeast. These are aimed a little bit to the north. This is on Wednesday night. Just but not strong. No real. There we go. There's some winds. 45-knot winds are pushing all due south. Looks like a tropical system. This is high pressure here, gradient between the two. The tighter, the closer low pressure and high pressure are, the tighter the isobars get. You generate wind, but you see it's all pushing towards Antarctica. Of no interest there. Then we get this system. Now we're almost a week out. We're on, let's go right here, Saturday. 45-knot winds. Okay, now I'm interested. We see something, and it is aimed to the northeast, and it is clear of the ice line at 63, but it's pretty much outside the Southern California swell window. Building pretty nice, targeting Chile and Peru, but again, that's almost a week out. Will do nothing. And there, 50-knot winds looking better. Also, a little interest here off south of Tasmania, 55-knot winds, if that were to hold. And it kind of looks like it might. Too early to tell. It's a week out. Never believe a model this far out. But if anything, certainly Chile and Peru looks to be getting, some storm activity, maybe some swell pushing in their direction. But the central part of the Pacific, no hope. And maybe the extreme far southwest Pacific a week out. We'll just have to wait and see. So let's examine the effect of those winds on the ocean surface. Again, here's our ice. We're 62, 63 north, maybe a little bit up. I'm up almost to 60 north in two spots. The lowest point is maybe 65, something like that. All right, so there's our system that we were looking at earlier, going right into the Ross Ice Shelf, of no interest there whatsoever. We're looking for seas 30 feet or greater. Now, remember, we saw some 35-knot winds in this area, 30, 35 knot. That's good for like 20, 22-foot seas, and that's exactly what we're going to see. And none of that, of course, will radiate or propagate northward in any meaningful way to generate swell of interest. So, again, okay, what do we got? 24-foot seas on Thursday night over a tiny area aimed north. Yeah, maybe 1 foot at 13 seconds or something like that, maybe. Then here's our fetch falling south. We saw that. System under Tasmania. We're into Saturday. We're a week away. And then, okay, here we go. So, Southeast Pacific, small area, 30-foot seas at 110 West California, Southern California, San Diego is like at 117 or something. So that's outside the California swell window and not aimed at California, again, targeting Chile and Peru. Kind of watch over here, see if something develops. Well, there maybe, just maybe, this system again, falling south, of no interest. And so, two systems of potential a week out. Never believe the model a week out. So where's that leave us? Probably not in anywhere good for the next week in terms of swell generation for the South Pacific. Let's go take a look up north. All right, so here we are, North Pacific, significant wave heights. We see some seas associated with what's left, tropical storm, maybe tropical depression lane. Generated, by the way, I generated some surf for Hawaii, nothing earth-shattering, mainly like 10-second period swell for the south shores of Maui and Oahu. Larger surf on the southeast shore of Hawaii, of the Big Island of Hawaii. Also a lot of wind as well. Anyway, we see something that almost looks like something trying to organize in the North Pacific, but not. Again, we're looking for, give us at least 20 or 25-foot seas. Little tiny area of 20-foot seas forecast on Tuesday, associated with a low-pressure system. There are a small gale. That's supposed to last 12 hours and be gone. At best, some maybe tiny little swell from the north shore of Oahu and Kauai, but that is even doubtful. New tropical system supposedly forecast to develop Tuesday evening, approaching Hawaii, getting stalled, and then watch this, it's going to move off to the north. And another system behind it as well, and supposedly another system off of the Philippines, that area. We'll see how all this goes. So this, whatever this system is, and it's not even believable this far into the future, we're almost a week out, certainly has the potential, though, to generate like a very northeast angled swell for exposed east-facing shores of the Hawaiian Islands. And this other system supposedly behind it. Nothing for the U.S. West Coast, though. And really, this guy here probably is not going to recurve. We got one more frame. There we go. Actually, what did that do? Oh, it was, look at that, turning off to the north, maybe. But again, a week out, don't believe it, especially on tropical systems. They're notoriously fickle. Nothing more than about 48 hours out is anything believable. So, but the models do suggest some hope a week out for the North Pacific. It's about that time when things start slowing down in the south and start picking up in the north. And so this would be about right on time. With no swell imminent, then what's next? Wind swell. Okay, so we're looking for north winds, the typical scenario. There's your high pressure, the Gulf of Alaska high pressure in the summer. Pretty strong, 1036 millibars, but displaced off to the west a bit, not really pushing up along California. And so typically what you get, high pressure out here, heat low inland, that tightens the isobars between these two, creates wind, north fetch here along northern California, and that can generate a pretty decent-sized wind swell in the summer, at least something to ride. But 20-knot winds as of Sunday morning, and the swell is what? Maybe waist high or so in the San Francisco area. Also that high, generating some limited fetch, mainly 10, 15 knots in pockets, pushing into the east shores of Hawaii, generating maybe tiny wind swell, but nothing of real interest. We get into Monday. The gradient tightens slightly over northern California, but not much, 20, 25 knots, so maybe some more wind swell. Same deal for Hawaii. Let's say barely 15-knot winds pushing there. So, and then as we get into later Tuesday, the gradient fades in California, but notice the continuity of the 15-knot wind starts building east of Hawaii from, what's that, 1, 2, 3, almost 1,200 nautical miles, so every 10 degrees on the equator is 600 nautical miles, but that's pretty close. We've checked it out. Let's say 1,000 nautical miles of easterly fetch here, aimed at the Hawaiian Islands, so maybe some wind swells we get into Wednesday. And then that starts fading, but notice the tropical systems here. Also notice nothing going on for California as we get into Thursday. And then here we go. Kind of an interesting scenario. High pressure is backing off. Two tropical systems working their way, getting actually pretty close to each other right here. A broad area of 20 to almost 25 knot fetch aimed right at the Hawaiian Islands. This is as of, let's say, Saturday night into Sunday. So again, we're talking a week out. But the potential, if everything comes together, and then both systems moving north of the Big Island, good potential for, we'll say, 11 to 12 second period wind swell pushing into the east shores of the Hawaiian Islands, if all goes as forecast. Also notice, we'll go back just a little bit here, looking at California. Here we are, starting Saturday, winds start building, high pressure starts moving east, building 20 to 25 knot fetch along the California coast Saturday night and into Sunday morning. So wind swell expected by next weekend for California. So, and another tropical system theoretically developing off of Mexico. So, yeah, this week, not a whole lot going on, but at least there's wind swell and maybe some tropical intermix swell for Hawaii as we get into the later part of next week. So some hope there. All right, let's take a look long term. What's going on with the MJO and El Nino? As usual, we'll start out looking or trying to examine what's going on with the MJO. The Madden-Julian oscillation, when in the active phase, helps support feeds energy actually into the jet stream in the northern hemisphere and helps support storm development, mainly in winter months in the Gulf of Alaska and the Dateline region. All right, so what we have, this is from the TAO buoy array. This is the East Pacific here, West Pacific here, New Guinea there. There's the equator. We see this, and so there's a series of buoys strung along the equator used for monitoring El Nino, but they also give us 5-day average winds over this area. You can see pretty strong out of the east the whole way, and building, this was not here a week ago, pretty strong easterly winds building on the dateline, but once you get just beyond the dateline, a rather light wind pattern indeed. And what we're really interested in, part 2 here, is the Kelvin wave generation area. This area from 170 west over to about 135 east, 5 degrees north and south of the equator. You get westerly anomalies in here, not westerly winds, just westerly anomalies. That would mean winds that are weaker, trade winds weaker than normal, if not blowing from the west in this area. That helps create a Kelvin wave, and a Kelvin wave, of course, is part of the cycle that helps feed El Nino. All right, so we look at the anomaly chart, what's going on. Wind differences from normal for this time of year, and what you see is, yeah, these easterly winds, the arrows here are pretty much dead or just sort of floundering around, suggesting that winds, these winds are normal for this time of year over this area. And even more interesting, yeah, these light winds here in the Kelvin wave generation area are actually weaker than normal, and that's the net effect is the same as having west winds, and that would help feed Kelvin wave development. So that is interesting. So what's the forecast for the next week? All right, so this is same sort of, this is 850 millibar zonal wind anomalies. So basically the east-west component of the wind, that's all we're looking at. And this is the whole planet on one chart. The area we're interested in is the Kelvin wave generation area. So the Pacific Ocean is basically between this tick mark and somewhere along in here. But it's that area between the date line and west of the date line. So between these two tick marks, and you just go down. When you see blues, that means easterly anomalies. When you see reds and oranges, westerly anomalies. We see that on, let's say, August 7th or 8th, we start having a pretty good solid patch of westerly anomalies through about August 17th. That would just about qualify as a westerly wind burst. 10 days of westerly winds or westerly anomalies in the Kelvin wave generation area. And then the model died out here, so just sort of ignore that stripe. The current forecast here, so here's today, what's going on. And you can see there, 120 east to 180, so it's 130 to 170 we're interested. So this area, you see, some westerly anomalies building. As we get further down the chart, they're supposed to start taking over a little more, and easterly anomalies dying out. So what's this mean? Well, up here was probably the active phase of the MJO supporting westerly anomalies. If anything, the inactive phase is probably trying to build, but having kind of a problem doing that. And if anything, just kind of a neutral pattern is developing. Interesting. Here's a little bit longer term view. This is from the CFS model, and this goes out a month instead of just 2 weeks. So same sort of deal. Kelvin wave generation area between these two tick marks, so that's what we're interested in right there. And the reds, there's our big, our westerly wind burst. And notice, see all this? These all the tropical activity, tropical systems that developed and associated with this active phase of the MJO in late July into about mid-August. So pretty productive. Also know that water temperatures were pretty warm in the East Pacific. And then here is probably the beginning of the inactive phase of the MJO cycle. So the MJO typically over the Pacific goes like 3 to 6 weeks active and then 3 to 6 weeks inactive. So we should be inactive here right now, okay, because we just came off a westerly wind burst in the active phase of the MJO. But what are we seeing? Westerly anomalies are still going on, and here's today's date, and here's the forecast, and we just see a whole bunch of westerly anomalies forecast in this chart. The last chart we saw, it showed just weak westerly anomalies, but building once we got about a week out. This suggests a pretty good looking picture starting a week from now into out a month from now. And that's kind of interesting. Also notice the purple here. The purple is the low pass filter. Those of you that know what's going on, basically when you see this, suggests a large pool of a bias towards low pressure in the West Pacific. And that's two contours, in fact, not just one, but two of them, suggesting perhaps the start of El Nino. We can look at outgoing long-wave radiation charts too. These go out 2 weeks, and you look here and you go, the blues are basically the active phase of the MJO, less sunlight reflectivity off the ocean surface. That's what this measures. That's what outgoing long-wave radiation is. Means more clouds, and that typically means low pressure, which means the active phase of the MJO. So some sort of weak active phase of the MJO signal, though we know that's not really the case, but basically a neutral pattern. That per the statistic model. Dynamic model says the same thing, maybe a tendency towards the inactive phase 2 weeks out, but I'm not going to believe a model 2 weeks out. Phase diagram charts, basically same sort of thing. We're looking for where the active phase of the MJO is and where it's going. So assume you're looking down on the North Pole. And the MJO, both active and inactive phase, travel from west-east from the Indian Ocean over the maritime continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean, round and round in a multi-month cycle. The heavy dot is where the active phase of the MJO is, and if it's inside this circle, it's considered extremely weak. The further out on the chart it is, the stronger it is. So a very weak active phase over the maritime continent, that would be like Bali. And forecast to kind of meander there for a couple days. Each dot is a day. And then slowly, very weakly, meander to somewhere over in the Atlantic. So basically no MJO signal. That per the ECMF model. The GEFS model, dynamic model, basically says the same thing, just an extremely weak MJO signal. Now, the key is you go, bummer. Why is there not a strong active phase of the MJO? Well, little history here. During El Niños, the MJO effectively disappears, but what replaces it is, instead of the active-inactive phase of the MJO, what you end up with is an El Niño base state that is like a nonstop active phase of the MJO that goes on for months. So, hey, maybe the demise of the MJO is a signal of something better to come in the months ahead. All right, so let's go look months ahead. All right, so this is the same sort of chart. Here's the date line. Kelvin wave generation area between these two tick marks. You go up, but past history is at the bottom of the chart. The forecast is in the future. Here is the active phase and that sort of westerly wind burst thing we saw back in the August time frame, the 10-day window that we think has created a Kelvin wave. Here's where we are today, and here's what's to come. And we're not overlaying anything. We're just looking. And what do you see in the Kelvin wave generation area? The whole way up here, we see nothing but westerly anomalies. The whole way to the end of the model. And that's November 23rd, 3-month run of the model. Don't believe it. It's a long ways out. But, hey, this model sometimes does a pretty good job of giving you a rough idea of what's coming. Right, so let's overlay the MJO. Dotted contours are the inactive phase of the MJO. So a very, very weak inactive phase of the MJO is in control right now. But what? There's westerly anomalies during the inactive phase. If anything, you should have easterly anomalies. So that's a head-scratcher, but that is also a clue of, hey, what's going on? Maybe El Nino. All right, and then we get into the active phase of the MJO, a very weak active phase. But notice these yellows here. That's basically, and note, remember that yellow there? Westerly wind burst, bump, 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 a couple of them, maybe. That's a sign that would transport a lot of warm water from the West Pacific to the East Pacific, and that would be a classic sign of El Nino. Then, of course, another inactive phase of the MJO in the late October, November timeframe, more westerly anomalies continuing. All right, let's overlay the low-pass filter. Here's where things really get interesting. You see this? This is the same thing as that purple contour on the previous chart. This is the area biased towards low pressure, and we see 1, 2 contours, 3 contours in control, the Kelvin wave generation area. This is like, the dateline West Pacific area, okay? And we see it's supposed to hold, the other part here is this, it's like at 125 west, which is just off the California coast now. And as we get up into October, it's supposed to push inland to like 115 west or so. So that's inland of California. So filling the entire Pacific basin from West Pacific to East Pacific as we get into fall with westerly anomalies in the Kelvin wave generation area, with westerly wind bursts embedded in that. This is all the typical signs of what happens when El Nino starts to develop. This is good news. We've been preaching this for weeks now. The point being here, the models have not changed. They're rock solid. And basically what this all this is past history here. It's evolving pretty much like what the model suggested. So maybe we're moving in the right direction. And then one last little bit here. So this chart shows you the strength of the active phase of the MJO. Doesn't show you where it is. But back in the last El Nino, January 2015, big spikes. This is during the peak of El Nino in April and July. And then in 2016, you notice MJO activity starts fading out now. And remember last summer and last winter, there was really no activity. One little, just no surf really. And then boom, we got a big push of the active phase of the MJO in February, and that created a Kelvin wave that has erupted already. And we see multiple spikes of the active phase of the MJO trying to materialize. And the thought is the MJO is really active in the fall and the winter. That's when it's strongest. The summer doesn't do a whole lot. The expectation is we're going to start seeing some spikes building as we get into the fall. All right, so much about the MJO. Let's see what's going on in the ocean, under the ocean surface. That gives us some clues, too, what's happening, right? So this is, again, from the TAO buoy array. West Pacific here, East Pacific here. These little X's are sensors on the anchor lines of the TAO buoys strung across the equator from just off of, let's say, the Galapagos over to New Guinea and beyond. All right, and what you see is 30-degree temperature, 30 degrees Celsius. That's pretty warm water in the West Pacific, not so warm water in the East Pacific. We're monitoring these isotherm lines here to see if any of this is moving off to the east. So this guy was about 162 last week. He's at 160. This is the 28-degree isotherm. And this guy was at about 120, I think, last week, the 24-degree isotherm. He's made a little bit of progress east. So not a whole lot going on, but let's look at differences from normal for this time of year, okay? And one thing jumps right out. Warm water, 3 degrees above normal. And then 2 and 1 degree filling the West Pacific. And so what is this? This is the Kelvin wave. Remember, we had westerly anomalies back in the August time frame. That westerly winds, or the equivalent of westerly winds blowing in the West Pacific. And that was even over the maritime continent. What it did is it took warm water was there, it started pushing it and spilling it into the western equatorial Pacific, and it's here building, pulling up, and as westerly winds continue to blow on the surface, it'll push more warm water into this pool and then start pushing it off to the east. And at some point, this bubble will eventually reach over here into the East Pacific and start erupting on the ocean surface. We saw that once already this year. This looks like Kelvin wave number 2 under development, which is good news. Let's look at some other data. So this is sort of model data, same thing as what we saw above, just a different model showing 1, 2, 3, 4, 5, 1, 2, 3, 4, 4.5 degree anomalies. So this one says the warm water is actually warmer than what was shown in the previous image, and pretty solid in a pretty solid area. Downwelling Kelvin wave pushing south, pushing down. But as it works its way east, it'll start working its way towards the surface and erupting. This right here is the last little bit of warm water associated with Kelvin wave number 1, slowly fading out. 1, 2, 3, 1, 2, maybe 2 degrees, about 1.5 degree anomalies right in this area. Erupting, here's the surface, erupting on the surface between 110 west to about 135 west, or generally in an area somewhere south of California, on the equator, just on the equator. So, another Kelvin wave in under development, it appears. All right, sea level anomalies. This is the same sort of deal. So what this does, this is from the Jason 2 satellite. And that satellite beams down radar on the ocean surface and can tell you either how high the seas are or how high the ocean is, just the height of the ocean as compared to normal in this area. So if you strip out all the wave height data, strip out all the wind swell data, strip out the tides, and what this says is there is a 0 to 5 to 10 to 15 centimeter bump over a giant. Here's the equator. There's South America. There's New Guinea right there. So this whole area from the maritime continents here, you can see warm water, or height anomalies officially, working their way from the maritime continent, spilling into the Pacific Ocean north of New Guinea and building in coverage here. What that means is warm water at depth expands and it creates a bulge on the ocean surface. And we're talking about a rather huge bulge here going from 15 south to about 5 north. And that's a lot of square miles of open ocean that are higher than normal. We're talking 5 to 10 centimeters, not very much. But what that means is that it's just another confirmation there's lots of warm water under the ocean surface here, and the assumption is that it is moving off to the east. And yet another view of that, upper ocean heat anomalies. So this is the upper 300 meters of the ocean, and it's just a way of measuring temperatures. So we're back last fall. Blues, here you can see, mean colder than normal, degree or 2 Celsius, below normal in the East Pacific. That's the sign of La Nina, right? Well, then in January of this year, a little bit of warm anomalies got pushed east, a mini Kelvin wave, and then the upwelling phase of the Kelvin wave cycle. And then in February, that big Kelvin wave we talked about started pushing east. It erupted, peaked out probably around in July. It started fading. There's your upwelling phase of the Kelvin wave cycle. Now here's Kelvin wave number 2 developing, and it looks pretty close to as big as Kelvin wave number 1. Kind of surprising, but because there wasn't that big of a westerly wind burst. But if El Nino's developing and just the trades in general over the entire West Pacific are fading, that just Coriolis effects and others just basically take warm water and start shoving it off to the east, and that's what appears to be what's going on. All it takes is a slackening of the trades for the natural tendency of warm water to take over and just push it off to the east. All right, so we've talked about the MJO. We've talked about subsurface. Let's go take a look at what's going on the ocean surface, because that's what really matters. Warm water on the ocean surface, especially in the East Pacific, affects the atmosphere above it and helps fuel the jet stream, again, in the North Pacific in winter months. So what do we have? Well, this is sea surface temperature anomalies. The reds are warmer than normal, and you can see we have a lot of warmer than normal water along the equator. The interesting part here is it's all north of the equator. Yeah, there's warmer than normal water south of the equator, but it's very lightly warm. All the concentration is north of the equator, and the area we're really interested in, the official El Nino monitoring region, is 120 west, so not over here, but from here, 5 degrees north and south of the equator, so from there to there, and in a box going out to about almost out to the date line, 170 west. So this area here is what is used to officially monitor El Nino. Now, the way this game is played, you get a Kelvin wave. It comes over to the Galapagos, Ecuador, Peru area, erupts here. The trade winds pick it up and then push that warm water into this area. Now, the interesting part is, one, all the warm water's, for the most part, north of the equator, and two, and you got this steady little drip pool of cooler than normal water sort of messing things up. So what's going on? This really doesn't look like El Nino. No, it doesn't. It looks like there's a battle going on between the remnants of La Nina and the early beginnings of something that looks like El Nino. And actually, that's exactly what's going on. We've been in La Nina, right? The atmosphere still is biased towards La Nina, but something's going on suggesting El Nino is trying to organize, but it hasn't quite stomped out the remnants of La Nina yet. So you get this yin and yang kind of thing going on with east anomalies causing upwelling, but you got all this warm water wrapping around it. So the atmosphere is not, they call it coupled, when the ocean and the atmosphere are sort of working together in parallel to build warming in this area. We're not there yet. Okay, so the El Nino's still in the very early stages. Now, if this were some monster El Nino, you'd start seeing signs of all this happening in the May, June time frame. And here we are, we're in almost September, and we're still playing sort of this yin and yang game. So that means that from an El Nino perspective, we're not going to have some monster El Nino this year. The best we'll probably eke out is a moderate El Nino. But compared to La Nina, compared to what we've had the past 2 years, that's got to be better than La Nina. All right, the last 7-day trend, what's going on? Well, we see the blues are pockets of cooler waters, water trending cooler. The reds, pockets of water trending warmer. So, again, the yin and yang thing. Yeah, I'm cool. No, I'm warm. I can't quite make up my mind what I want to do. It's the two phases of the atmosphere battling it out. Basically, we're in transition, right? And that would sort of explain why we have no storm development in the southern hemisphere and the fall season isn't really going yet. The atmosphere is trying to sort itself out. We're kind of, if you consider La Nina on the negative side of the scale and El Nino on the positive side, we're at like dead zero right now. Full-on battle, fighting it out. The energy can't quite align itself to do anything yet. But the thought is, once El Nino starts getting the upper hand, it'll do so probably pretty quickly. And the thought is it's probably going to do it in the next month or so. Also, remember, you got the change of seasons coming, right? So as you get into the mid-September-ish time frame kind of thing, late September, things should probably start changing pretty quickly. And then we'll get a much better sense of what's going to happen with our developing El Nino. Irrespective of all that, you just sort of look at the overview. What's going on? Well, there isn't a whole lot of this is the last of La Nina hanging here. Yeah, we got this little thing going on here, but look at how much warmer than normal water there is over the entire equatorial Pacific, save that little pocket, this little bit down here, okay? And you wonder why you're getting a lot of hurricanes relative to why? Well, look at all this warmer than normal water here. So plenty of fuel to support tropical storm development. You can see right here, this is not cooler than normal water because of its inherent coolness. It's because there's been a series of nonstop tropical system causing upwelling here, but underneath there's still much warmer than normal water going on here. And then even up in the upper reaches, Southern California, why is your water temperature so warm? Well, look, little pocket right there. Now, is that El Nino related? We're going to say no, not at this point in time. It would have to build up and be more up into covering all of California. And if you get into the San Francisco area, temperatures are basically normal, maybe 1 degree above normal, but nothing earth-shattering like what's been happening in the San Diego and the southern half of Southern California region. Anyway, but there is some sense that warming is building, and that it's certainly not cooler than normal, and that maybe El Nino could metastasize in the next couple of months. Let's look at some trends. So this is the Nino 1.2 region. It's just average water temperatures. So this is the area, Galapagos, Chile, Peru, sort of the very far East Pacific. And we know it's kind of cool there. And sure enough, today's reading, 0.5 degree below normal, 0.532. You can see the trend. It's been hovering right about 0.5 degree now for a month or so, but prior to that it was cooler, and that was down to almost a whole degree. So average, the trend is warming, but not markedly slow, and surely taking its time. The Nino 3.4 region, the official El Nino monitoring regions, today's value is plus 0.195, so 0.2 of a degree above normal, basically, and it's been holding there as well for about the past month to month and a half. Yeah, it was a little bit warmer than that before, but when we were during La Nina, it was down. You can see the trend was definitely up. We're holding flat right now. This is sort of that yin and yang battle going on, but the expectation is that this should be working its way warmer, assuming the next Kelvin wave gets its act together, assuming it makes its way across the Pacific in the next 2 to 3 months, assuming pockets of easterly anomalies fade out. You know, there's a lot of assumption going on here as to how all this exactly will materialize. So what's going on in the atmosphere above the ocean? Maybe that can give us some signs of what's happening with El Nino, La Nina. All right, so the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. Negative numbers suggest the active phase of the MJO. Negative numbers over a long period of time suggest perhaps El Nino. Today, the value, positive 3.82, and you can see it's been positive the past couple of days. We had a pretty good run there of negative numbers down to minus 31 August 10th. That was during the active phase of the MJO. So the MJO is turning inactive. It is not unexpected that we're starting to see some positive numbers here. But the 30-day average sort of takes out some of the noise. And what do we see? We see a steadily negative trend, minus 6.04, peaked out at 6.36. That was probably the peak, and this is sort of a lagging indicator. It runs probably maybe 15 days behind what's actually going on in the atmosphere. So yeah, the active phase of the MJO was in control, starting to lose some of its grip. The 90-day average, we use that to monitor El Nino. So the cool thing here is, yeah, it's been kind of negative, but not much so. And then it's got much more negative today, minus 3.78. But we know that if the inactive phase of the MJO is setting up, this will probably rise a little bit. But we suspect that it is probably not going to rise a whole lot because it's a very weak inactive phase of the MJO. And if in fact El Nino is building, that would mean pressure in general would tend to be lower over Tahiti, and that might keep feeding this down negative, or at least not let it get and not start rising much from where it is today. And then finally, the problematic ESPI index. So this is much like the Southern Oscillation Index, only it measures differences in precipitation between the area north of Darwin, Australia, and Tahiti. If you have a negative number, like today's value, minus 0.05, that means you have less precipitation than normal in here. And if we have warm water over this area, you have more evaporation. One would expect you to have more precipitation, and this would go positive. Well, it actually was barely positive last week, and I think the week before that it got up to maybe plus 0.1 or 0.12, something like that. You know, we really want to see it at plus 1 or something like that, a whole standard deviation wetter than normal, but we're not there yet. So this is all, what this speaks to is that same yin and yang thing we were talking about. Well, La Nina's gone, El Nino's not here yet, we're just basically normal floating around here. What we want to see, and we think we are going to see it if El Nino builds, is that this will slowly start getting more and more positive, meaning more rainfall here, and that would be in sync with warming surface temperatures in here, and that would be in sync with more westerly anomalies here. And we saw, of course, on the charts, westerly anomalies forecast for the next 3 months, so that means all this should push us towards an El Nino pattern. And so that leads us to the forecast for the Nino 3.4 area, sea surface temperatures. According to the model, if you believe it, temperatures are supposed to start rising significantly as we get into early October, 1.2 degrees above normal, pushing up to 1.5 degrees above normal, and holding the whole way through winter, even into next spring. That certainly would qualify as an El Nino. So that's one model. Let's look at every model that we have on the planet used for measuring El Nino, and they're all saying, in effect, the same thing. Some sort of warming, August, September, October, November, December. Now, not quite as warm. We can actually look, here's a list of all the models, dynamic models, statistic models, but we can go down here. Here they all are, month by month. You can pick the model of your choice, go to the website. Here's the average of the dynamic models, peak somewhere around, like 1 degree, 0.95. The statistic models, saying about the same thing. So somewhere in the vicinity, I'm actually looking here, they don't have the all of them summed together, but you get the sense that somewhere around a 1 degree above normal peak, which is a little less than what we saw in the previous model, but still some sort of El Nino. All you need is a 0.5 degree for 9 months, and you've got El Nino, or 3 consecutive 3-month running periods. So, yes, some sort of El Nino is forecast for this winter. So to put a bow on it, right now, no clear sign of any swell production from the southern hemi or the northern hemi for the next week. Tropical activity certainly might make things interesting for Hawaii. Potential, at least, for like northeasterly swell there. Certainly some wind swell for California is possible, but no real swell yet forecast. The good news is it appears our El Nino is trying to move forward. We're in the battle right now. We're at the turning point. Yeah, we're neutral, effectively. Are we going to tip towards El Nino? All the models say so. We'll believe it when we see it, but we're cautiously optimistic for the summer and fall. So that is good news. So we got to wait this out another, probably 2 weeks, 3 weeks, something like that. And then things should start becoming more apparent with the change of season. That should start help feeding and pushing us towards an El Nino-like pattern. All right, so that's it for this week. We will not be doing this next week. We're taking a little break, but the following week we'll be back in. You know where to get to all the links and all the data, and you've been following us, so you're probably pretty good at deciphering the data. So if you're really dying, you can take a look, do the work yourself, and check up and see what's going on. Otherwise, we'll see you in 2 weeks. Thanks for watching. Bye-bye.